right, today we're going to be looking at a single replacement reaction. So I have an empty potato chip can, I have 6 molar hydrochloric acid, and I have pure zinc. What I'm going to do is a single replacement reaction. So when I take pure zinc, I'm going to put it in a beaker, and I mix it with hydrochloric acid. There's going to be a single replacement reaction where zinc is going to come in and kick out hydrogen. Hydrogen is then going to form a gas. I am going to then trap that gas in this chip can. All right, so let's do that and see. Now, just so you know, I poked 2 little holes in the bottom of the chip can for what we're going to do next. So I'm going to mix that up, and you'll start to see that it's starting to bubble and fizz. So that is a reaction. We're going to now trap that and wait for that hydrogen gas to build up inside the chip can. Once we do that, we will then put it on this lid and we'll test to make sure that hydrogen gas was formed. We're going to just take a little match, light it up to see if it actually ignites the hydrogen gas. So we'll wait here, we'll let that hydrogen gas collect, and then we'll try it out. While we're waiting for that hydrogen gas to build up, let's look at the actual single replacement reaction going on between zinc and hydrochloric acid. If we look at the single replacement reaction, what we did is we took pure zinc and put it and mixed it with hydrochloric acid. Now, as you know, this is a potential single replacement reaction where zinc can kick out hydrogen. If zinc happens to be stronger than hydrogen, zinc will come and kick hydrogen out. And that's exactly what happens and why we see the bubbling and fizzing going on in the reaction. So that means that hydrogen is now by itself. But as you know, hydrogen is never alone. When it actually forms its pure form, it actually doubles with itself because it's diatomic. What also forms then, of course, is zinc and chlorine come together. But when zinc and chlorine come together, it's not just ZnCl. Because it's an ionic compound, zinc comes together with a 2+ charge originally, and chloride comes together with a -1. So that means that you're actually going to need 2 chloride ions for every zinc. So it becomes ZnCl2. Now that that single replacement reaction has happened, we can balance this out. We need a 2 here to make sure we honor the 2 hydrogens and 2 chlorines to balance it out. But that is an example of a single replacement reaction. Everybody's going to get 1s there to just show that we balanced it out. But again, a single replacement reaction only happens if that solo element is stronger and more chemically active than the cation in the compound. All right, back to the reaction. Let's see what happens. So we've been letting the hydrogen gas build up inside the chip can. I'm going to take a look. See, it looks like the hydrogen gas has been building up. So what I'm going to do is I'm going to take my chip can, I'm going to put the lid on it, and I'm going to move this far away. This reaction is still going on. The zinc is reacting with the hydrochloric acid. But now what I'm going to do is test it out and light a match to see if hydrogen gas is actually there. So let's see. Whoa! Okay, there you have it. That was definitely hydrogen gas inside of that chip can. You can feel the heat given off. And that's a second type of reaction. When hydrogen gas reacts with the oxygen because of the energy, you get a combustion reaction. All right, but in the end, that was single replacement, us doing it in a fun way. Take care, science fam.